Hello everyone, welcome to Samadhan Life Science. In today's video, we will discuss about a topic that occurs frequently in GATE exam, geometry and magnetism of coordination complex. To solve this kind of problem, we will learn a simple method. So to predict the geometry or isomerism, we will go step by step. So first, let's calculate the oxidation state. So if we have a complex, something like this one, then 6 minus charge from the 6 cyanide ions, and then outside we have 3 minus. So to balance out the whole complex, we will have plus 3 for this iron. Similarly, if you have a neutral ligand like this, water, and you have plus 3 outside, then this is the charge of this cobalt, right? Next, you have to see the electronic configuration specifically for D. So let's take the same iron. We have argon and then 3d6 4s2 for neutral iron. So to form the cation, first the electrons will go from S and then from D. So Fe3 plus will have 3d5 only. Next you have to see the ligand strength. So we will use this spectrochemical series. So in this end we have the weak field ligands, and in this direction we have the stronger field ligands, right? So for these weak field ligands, they will create a smaller splitting energy for the complexes, which results in a high spin complexes. That means the electron can remain unpaired and the energy gap between the splitted d orbitals are lower, so electrons can go easily to the higher energy d orbital. Similarly, for the stronger field ligands, the crystal field splitting energy is larger. That means the electron will remain paired rather than going to the higher energy d orbitals, which means low spin complexes. Now let's see the problems. So in this problem we have three different nickel complexes. Let's see one by one. So first one is CN6 2 minus. So nickel is in plus 2 oxidation state, which means 3d8. Now this cyanide is a stronger field ligand, which means the splitting energy is higher. So in 3d8 they force the ligand force the electrons to pair up. So 3d8 in these 4 orbitals, and this d and next s and v are empty, which means dsp2 hybridization, which means square planar geometry. Now this square planar has the orbitals like xz, yz, and then dz square, xy square minus y square, right? So 8 electrons, 2, 4, 6, 8 all paired up. That means this is a diamagnetic complex. Now we have the geometry and magnetism both, right? Now the next one, NiCO4. This is also a strong field ligand. But here nickel is in 0 state because CO is a neutral ligand. So Ni0 has 3d8 4s2. Now forming this complex forces this 2 electron to go to d8. That means it will be d10, all paired electron. But this d10 means no d electron is left to accommodate the incoming electrons from CO, which means only S and P, next S and P are available, which means sp3. So tetrahedral geometry. And d10 all electrons are paired up, that means diamagnetic. Now the last one, NiCl4 2 minus, here again nickel 2 plus, which means 3d8. But this Cl is a weak field ligand, which means high spin tetrahedral complex, and the electronic distribution will be something like this, which means that left 2 unpaired electrons, that means paramagnetic. Now let's see the options. Both CN4 and CO4 are square planar. No, that's not right. CO4 is tetrahedral. CN4 is diamagnetic. Cl4 is paramagnetic. Yes. CO4, Cl4 are paramagnetic. No. CN4 is square planar. Yes. Cl4 is tetrahedral. Yes. I hope you understood. Now the next one. In this, we have four different complexes of cobalt and we have to determine which is correct. So for this tetraamino complex, ammonia here act as a weak to moderate field ligand and cobalt is in +2 oxidation state, that means D7. So for this weak to moderate field ligand, we don't have a higher energy, so the splitting energy is lower. That means no one is forcing the electrons to pair up. 7 remains like this. We only have S and P remaining, so it will have sp3, that means tetrahedral geometry. So this is not right. Next, COEN3. EN3, that means ethylene diamine, is a bidentate ligand forming a complex something like this. Bidentate means two donor center in one ligand. This does not have any center or axis of symmetry, that means it shows optical isomerism with two enantiomers which are called delta and lambda. So this is also not right. Now the next option is hexa aqua complex of cobalt. Here water is a weak field ligand, but cobalt is in a higher oxidation state, +3. This higher oxidation state attracts the water molecule towards its nucleus more forcefully. That results in a higher splitting energy, which means in this octahedral splitting, the electrons remain paired up and doesn't go to the higher energy d orbital. Now this cobalt 3 is a d6 system, that means all 6 electron will be here all paired up, that means this is diamagnetic. So this is also not right. Now the next is pentaamino chloride complex. Whether the ligand to metal charge transfer happen or not, here this chloride has a non-bonding high energy p orbital and here chlorine is in +3 again, which means higher oxidation state and a MTEG, which can accept the incoming electron from this chloride, which means ligand to metal charge transfer happen if a photon of light hits this complex. So this is our answer. So I hope you understood the concept and you don't have to memorize all the complexes to answer this question. Just apply these rules and solve the problem. Thank you for watching. See you in the next video. Bye bye.